a mathematical model of physical systems. A physical system is represented through mathematical modeling is called mathematical models. Physical system is a system in which physical objects are connected to perform an object. The idealized physical systems is called physical models. By the definitions, a physical system is a system in which physical objects are connected to perform an objects. The idealized physical system is called physical model. There are two type of models. First is mechanical system. Second is electrical systems. Now first, mechanical systems. Mechanical systems. What is mechanical systems? All the mechanical elements, mass element, damper element, spring elements, so are connected in controlling purpose in a system is known as mechanical systems. All mechanical systems, are classified into two types: First is mechanical translational system, and second mechanical rotational systems. Mechanical rotational systems. Now, first, mechanical translational systems. So, in mechanical translational systems, input is equal to force. The force is applied as a input and output linear displacement. Linear displacement x or linear velocity v. The three ideal elements are: in mechanical translational systems, there are three ideal systems. First is mass element. Mass element, that is a mass, force F, x is the displacement and v is the velocity. The F force acting on mass m body, the displacement x and velocity v. From in this figure, force is equal to m dv बटे dt and force is equal to m d square x बटे dt square. We know that force is equal to m a. This is the basic formula of the mass body displacement. Second is the damper elements. So the damper elements look like this. Force acting x1, v1, x2, v2. F or B. Force is equal to V1 minus V2 V, and force is equal to T by T dt x1 minus x2 is equal to dx upon dt. Third, a spring element. A spring elements, that is called a stiffness. So the spring elements force acting S1 B1, and here S2 V2, the force. The spring constant is equal to K. So the force acting on the spring is equal to F is equal to K function of V1 minus V2 dt is equal to K direction of V dt, and B is equal to force is equal to K x1 minus x2 is equal to kx. Second is the mechanical rotational systems. Mechanical rotational systems. There are two mechanical systems, translational systems and rotational systems. In rotational systems, input is torque T and output is equal to angular displacement theta or angular velocity Ct omega. There are three ideal elements in mechanical systems. So the ideal element in mechanical systems, first is inertia element. Inertia element. So what is the inertia element? J that is omega, theta and torque. Torque is equal to J d omega by dt, and P torque is equal to J d square theta by dt square. And second is torsional damper element. Torsional damper element. Theta 2 omega 2, theta 1 omega 1, that is T, F or B torsional. A is equal to in the A, T is equal to function of omega 1 minus omega 2 and torque is equal to function of d बटे dt theta 1 minus theta 2. And third ideal element a spring element. Torsional spring elements look like this. K is the spring constant, torque, theta, angular velocity. So torque is equal to K integration of Wt and torque is equal to K theta. This is the spring elements. So in the mechanical modeling systems, there are the basic equation of the translational and rotational mechanical systems. The next topic of the mathematical model of the physical systems is mathematical model of elliptical system. So what is the elliptical systems? The elliptical systems are analogous to voltage, current, resistance, inductance, etc. Inductance, resistance, capacitance, current I, voltage V. V is equal to V1 plus V2 plus V3. V1 is voltage across inductor, V2 is voltage across resistor, and V3 is equal to voltage across the capacitors. So V is equal to L di बटे dt. Voltage across inductor L di by dt and voltage across resistor IR plus voltage across capacitor integration of I dt. I is equal to dq बटे dt and Q is equal to charge. So this equation may be written as L dq बटे dt plus R dq बटे dt plus Q but upon C. Next electrical systems look like this is the series systems and this is the parallel systems. That is the parallel systems. Inductor, resistor, capacitors. Sorry. That is the sources, current source. Current here I1, I2, I3, and voltage across inductor, resistor and capacitors are equals. So current is equal to I1 plus I2 plus I3. So I is equal to current across the capacitor C dV by dt, and current across R is equal to V upon R plus, and current across inductor is equal to 1 upon L integration of V dt, and V is equal to d phi by dt. And what is phi? Phi is equal to flux. So this equation can be written as I is equal to C d square phi by dt plus 1 upon R d phi by dt plus phi upon L. So this is the electrical systems, electrical mathematical models. Next topic is the analogy of the electrical system and mechanical systems. Analogous systems. So what is the analogous systems? The electrical equivalent of mechanical elements are known as analogous systems. The comparison between mechanical and electrical elements is known as analogous. Next is analogous systems. So what is the analogous systems? The electrical equivalent of mechanical elements are known as analogous systems. The electrical equivalent of mechanical element are known as analogous. Analogous systems. So first is force current analysis. Force current analysis. Force F analogous of voltage V, mass M analogous of inductance L. A stiffness K analogous of capacitance C and damping coefficient B analogous of resistor R and displacement X is analogous of charge. So this is the analogous between force and current, that is the mechanical system and that is the electrical systems. Next, translational and rotational analogy. Translational and the rotational. In the translational, force is analogous to torque and acceleration is analogous to angular acceleration, velocity analogous to angular velocity omega, displacement analogous to angular displacement theta, mass analogous to moment of inertia J, and damping coefficient analogous to rotational damping coefficient B, and a stiffness analogous to torsional stiffness. So this is the analogous between translational and the rotationals.